2006 Canadian Open Mathematics Challenge, Part B. Piotr places numbers on a 3x3 grid using the following rule, called Piotr's principle. For any three adjacent numbers in a horizontal, vertical, or diagonal line, the middle number is always the average mean of its two neighbors. Using Piotr's principle, determine the missing numbers in the grid to the right. All right, let's work with this here. So we're concentrating on this one, right? Okay, so I think we can just make that again. It's not a big deal. It's a pretty small grid. It's only 3x3, so here we go. And what did they give us? They gave us 3, 19, and 8. Okay, so 3, 19, and 8. So the principle is that if you have a grid and let's say you've got two numbers in there, say this is A and this is C, then the number that goes in here is the average of those two. So if that's B, then B is equal to A plus C divided by 2. So that's the basic principle. So I think we can do that just by the three numbers that they've given us. We can fill out the entire table. So the number that goes in here obviously is the average of 3 and 19. It's two neighbors, so 3 plus 19 divided by 2, and that is 11. Okay, so far so good. Now this number probably will be next. Let's say that number is x. That means that 3 plus x divided by 2 is 8. So that means 3 plus x is 16. X therefore is 13. So put that in there, 13. And whichever way you want to go, let's try this number in here. That number is going to be 13 plus 19 divided by 2, right? Because diagonals behave in the same way. So that's what, 42, sorry, 32 divided by 2, which is 16. Okay, great. And then basically they just kind of keep going like this. This number in here, if you call it whatever you want to call it, let's say y, that means that 8 plus y divided by 2 will be 16. So that means that 8 plus y is 32, and therefore y is 24. So there you go, 24. This number in here, if we call it, say, z, that means that z plus 19 divided by 2 is 24. So z plus 19 is 48. So z is equal to 29. And then finally, this and this, the average of that would be this number. So 13 plus 29, which is divided by 2. So that's 42, and that is 21. So there we go. We just filled out the whole table based on that principle right there. That's 11, that's 16, 24, 29, 21, and 13. So there you go. Next question. Determine with justification the total of the 9 numbers when the grid to the right is completed using Piotr's principle. Okay, so now we got this situation. Okay, x5 and 23. All right, so I think I can do that. x5 and 23. So we've got an x, a 5, and a 23. Now that what they're saying is they want you to figure out the entire table's sum. All right, so this is a little bit different. Let me just put in some letters first to represent. We got an x, so I'll put a y here, a z here. This would be x plus y divided by 2, based on the principle. This actually we can get an actual value. So there'd be 5 plus 23 divided by 2, which is 28, 14. Any other numbers I can get here? I don't think so. So I have to introduce another letter, and therefore this would be w plus z over 2. All right. So in the end, we have to add up all of these. So that would be x plus y over 2 plus y plus 5 plus 14 plus 23 plus w plus z over 2 plus z. That's the sum of all the numbers, and that's what they want. Okay, let's see if I can do anything here so far. These two I can add. That would be 3 over 2 x plus y. And these ones I can add also. So that's also going to be 3 over 2 w plus z. And then the remaining is just a number. It's 42. These added together. Okay, so that's about as far as I can get. Oh, but I can factor out the 3 over 2. And if I do, I get x plus y plus z plus w. Well, it's not in order, but you understand. Okay, so if I can get the sum, x plus y plus w plus z, I will be able to get the total. So now let's go back to here. Let's see here. Where do I want to go? I think I'll work with this diagonal here. That's going to help me. That diagonal tells me that x plus z over 2 is 14. So that's very helpful. That tells me immediately that x plus z is 28. Okay, that's a pretty good progress there. So I got x plus z. What do I need? I need y plus w. Y plus w. Can I get that in any way? Well, this immediately over here tells me that y plus z over 2 is 23. So that means y plus z is 46. Okay, that's pretty decent progress. Anything else? Yeah, y plus w is right here. It's right here, the other diagonal. Okay, so that means that y plus w over 2 is 14, so that means y plus w is 28. Okay, I think I got it then. So that means that x plus z is 28, so put that in there. And then y plus w is 28, so put that in there. Okay, figured it out. All right, so we got 28 plus 28, which is 56, times 3 divided by 2, it'd be 84. And then we have to add to that this 42, and that would be 126. Okay, so there we go. That's the answer to the question. Okay, the final part, determine with justification the values of x and y when the grid to the right is completed using Piotr's principle. So this grid now is a little bit different, and they want you to figure out the values of x and y. So we got x, 7, 9, y, and 20. So they've given us quite a bit of information. So let's see what we can do using the same principle. Okay, so let's see here. Where do I want to proceed here? Anyway, really, that you feel comfortable. I'm going to introduce another variable, z, and then I can kind of make some equations pretty quickly. Z plus 20 divided by 2 is y from this right here. And then from this right here, I can get that x plus z over 2 is 7. And then this one will give me that z plus 20 is 2y, and therefore z is 2y minus 20. This right here gives me that x plus z is 14, and therefore z is 14 minus x. Okay, so since z is that and z is that, we can equate them. 2y minus 20 is 14 minus x, and therefore it looks like x is 34 minus 2y. Okay, and then where else can I go here? I think we'll concentrate on the one in the center. The one in the center is interesting because it is, if you look at it from this diagonal, it's x plus 20 divided by 2. But if you look at it from this horizontal, it's 9 plus y over 2. So that means that x plus 20 over 2 is equal to 9 plus y over 2. So that means that x is equal to y minus 11. Yeah. Okay, so then we just equate these two now. And that would give me the value for x, or y. Well, both actually. Y minus 11 is 34 minus 2y. So that means 3y is equal to 45, and therefore y is equal to 15. And then substitute that back into here, and you get x is equal to 4. So x is 4, y is 15. In the diagram, circle x squared plus y squared is equal to 25 intersects the x-axis at points A and B. The line x equals 11 intersects the x-axis at C. Point P moves along the line x equals 11 above the x-axis, and AP intersects the circle at Q. Determine the coordinates of P when triangle AQB has maximum area. Justify your answer. Let's see if we can label this as much as we can. First of all, the circle is x squared plus y squared is equal to 25. So that means the radius is 5. So that means B, this will be 5, 0. This will be negative 5, 0, that A. Q will, well, Q we don't know actually quite yet. But this point up here, that's going to be 0, 5. And then anything else? P is on the line x equals 11. So this is, C is 11, 0. So P is 11 something. So I'll just put 11 and then some coordinate Z. I don't know what that coordinate is yet. And I think that's all that I know for labeling purposes. Okay, so let's concentrate on part A now. Determine the coordinates of P when AQB has maximum area. All right, so that means they're joining the coordinate Q to B, and then they've got this triangle now, and they're saying you got to maximize the area of that triangle. Okay, well, the area of that triangle will be maximized when the height is maximized, and let me explain. So we got triangle AQB, and like any triangle, the area is 1/2 base times height. The base is AB, so AB, and the height, well, the height, I'll just draw a little line there and call that H. So I'll just call it H for height. Now, here's the thing. AB is fixed in this question. AB is 10. It's just the distance from A to B, which is from -5 to +5, which is 10. So really all we have is 1/2 times 10H. And how do you maximize this, which is essentially 5H? Well, it's maximized when H is maximized. Correct? So what's the biggest you can make H? Look at the diagram. The biggest you can make H is if Q was sitting right here. If that's the highest, because Q, let's see here, it says in the question, right? It's basically a point on the circle. Point P moves along x equals 11 above the x-axis, and AP intersects the circle at Q. So Q is on the circle. So when Q is here, that would maximize H. H would essentially then be 5. So maximized when Q has the coordinates 0, 5, and that would mean H is 5. And what do they want? Determine the coordinates of P. Okay, that's a little bit different. So if H is 5, this becomes 25. Now they want the coordinates of P. Okay. All right, I got it. So if Q is here, then that means the line would go like this, and then P would end up being here. Right there, that would be P. Okay, I got it. And then it's going to still have some coordinates, 11 something. So we got to figure out that something. Okay, not a problem. So we can figure out the equation of the line first, the line from A to P, this line right here. So like all lines, it's y equals mx plus b. And the slope we can get 5 minus 0 over 0 plus 5. And that is equal to 1. So m is 1. So the line is y is equal to 1 times x plus b. Correct? So then to get b, we just substitute a point. I'll just substitute this point. So that means when y is 0, x is -5. So that means b is equal to 5. So the equation of that line is y is equal to x plus 5. So to get the coordinates of p, we just substitute in 11 for the x value. So that means y is equal to 11 plus 5, and therefore y is 16. So the coordinates of p, well, 11 we already knew, but now we know the y coordinate, it's 16. So there you go. Okay, moving on to part B. Determine the coordinates of p when q is the midpoint of AP. All right, so slightly different here. So let's clear all this and start fresh with a new clean diagram. So they want you to choose q to be the midpoint. So you use the midpoint formula to figure out the coordinates for q. So it's the midpoint of AP. So p, well, p we don't know actually. Do we know p? Not yet. Okay, so I've got to give it a certain value. I'll just call it z again. 11 we know because it's on the line x equals 11. And then a we know that is negative 5, 0. Okay, so using the midpoint formula, q is going to be 11 plus negative 5. So that's 11 minus 5 over 2. And then 0 plus z over 2. So that basically is 3z over 2. Okay, so that's now the new coordinates for q. 3 and z over 2. Okay. All right, so what do they want us to do? They want us to figure out the coordinates of p. All right. Okay. So q is interesting because q is on this line. So whatever point q is, it will satisfy that equation. So I guess I'll substitute it in, and I should be able to figure out z. So I'm going to substitute into this equation this coordinate z, oh, right here, z over 2 and 3. So x is 3, and then y is z over 2 squared, and that's 25. So that's 9 z squared over 4 is 25. So that means that z squared over 4 is 16, and therefore z squared is 64. Z is equal to 8. Z is 8. So the coordinates of p would be 11, 8. Yeah, that's it. Okay, moving on to part C. Determine the coordinates of p when the area of AQB is a quarter of the area of APC. Justify your answer. All right, let's see here if I can move this up a bit. All right, so this time they're saying that when you have triangle AQB, its area, it's a quarter the area of triangle APC. Okay, so let's fill in as much as we can. AQB would be 1/2 base times height. The base is AB. The height, well, the height we don't know. Right, just as before, I had drawn a height like that. So I'll just do that again and represent that with an h. And on this side, we've got 1/4. And then APC, 1/2 base times height. So the base is AC, and the height is PC. Yeah. Okay, I think some of this we know. AB is just the distance from A to B, and that's 10. We know that already. And this is going to be 1/8. AC is the distance from -5, 0, to 11, 0, so that looks like 16. And then PC we don't know. Actually PC we don't know, but we can label it. If we make the coordinates just as before, 11z again, PC is just z. So that's z. Okay, so this becomes 5h is equal to 2z. Okay, that's a pretty good. And then I can just say h is equal to 2z over 5. All right. The next step, I think, would be to look at line AP, which is this line right here, and make an equation for it, if we can, at least in terms of z, and that's going to help us. Okay, so the line AP, that looks like, first, of course, I will figure out the slope, z minus 0 and then 11 minus 5, so 11 plus 5, so that's going to be z over 16, correct? All right, so y is equal to mx plus b is the equation for any line. So we've got y is equal to z over 16 x plus b, and then I can substitute this point to figure out my b. When y is 0, x is negative 5, so I've got negative 5 in here, so it looks like b is 5z over 16. So my equation is y is equal to z over 16x plus 5z over 16. All right, that's pretty good progress, I think. And then I think what's the next step here? We're going to have to utilize Q in this because Q has the coordinates. Well, I actually don't even know what the coordinates are, so I'll just label something A, B, but B is the height, so I can just write AH like that. And we figured out over here, we've got H in terms of Z, so A 2Z over 5. And since Q is also on the line AP, it must satisfy this equation. So that's what I have to do now, substitute that point into there. So I've got 2z over 5 is equal to z over 16a plus 5z over 16. Okay, so that means, let's see here, the z's cancel, so I'm just left with 2/5 a plus 5 over 16, and that means 32 is equal to 5a plus 25, and therefore 7 is equal to 5a. A is equal to 7 over 5. Oh, that's good. So I've got actually a numerical value, and that's going to be helpful. And now to figure out this component of the coordinate, I would just have to sub it back into that formula for the circle, which is right here, because since Q is on the circle, x squared plus y squared is 25. So let's do that. X squared plus y squared is 25, and Q has the coordinates a 2z over 5, right? Right here, a 2z over 5. And we just figured out that a is 7 over 5. So then I can figure out z by substituting this coordinate into here. Okay, let's do that. So we got 7 over 5 squared plus 2z over 5 squared is 25. So that means we have, let's see here, 2z over 5 squared is equal to 25 minus 49 over 25. And then if I do this fraction, it'll be 25 times 25 minus 49 over 25. This is 2z over 5 squared. And that looks like 625 minus 49 is 576 over 25. Okay, that's good, because that's a perfect square. So if I square both sides now, or sorry, take the square root of both sides, I get 2z over 5 is 24 over 5. So that means 2z is 24, so z is 12. Okay, it all worked out nicely. So that means that this is, p is what they wanted, right? They wanted the coordinates of p. So this is 11 and 12. So it's a little bit more challenging than the previous ones, but we got the answer. In the diagram, trapezoid ABCD has parallel sides, AB and DC, of lengths 10 and 20 respectively. Also, the length of AD is 6 and the length of BC is 8. Determine the area of the trapezoid ABCD. Okay, they don't tell me if it's isosceles, right? So I can't assume that this is equal to that. So that was a tempting assumption, but I don't think I can assume that. So let me just draw two perpendiculars like that and that. These are perpendicular, and then off we go. So what did they tell me? AD is 6, BC is 8, this is 10, and this is 20. Okay. So I think I'm going to label this h for height. From here to here, I will call A, and then from here to here, I will call B, and therefore, let's see here, this distance is just going to be 10 because it's the same as that. So that's 10 in there. Okay, and then the area of a trapezoid is always given by, let me just bring this down here. The area of a trapezoid is always as follows. Area would be, let me just draw a little basic trapezoid here. And this is the height, and this is x, and this is y. The area is x plus y divided by 2 multiplied by h. So in this case, the area in our trapezoid down here would be 10 plus 20 divided by 2 times the height. So that looks like 15h. So I guess all I have to do is figure out h and I'm all set. So that's where these triangles will come in. These triangles. And there's going to be a couple Pythagorean relationships. So the first relationship is a squared plus h squared is 6 squared. And the second relationship is that b squared plus h squared is 8 squared. Correct? And we also know that a plus 10 plus b all the way is 20, right? That's that whole side of that trapezoid. So that means a plus b is 10. And I think that's it. Yeah, I think that's it. And we can isolate this, that a is equal to 10 minus b. I think that should be enough to solve. Yeah. Yeah. Okay. Let's work with this now. So this equation, we will have that we got 36 is equal to a squared plus h squared, but this is a, so 10 minus b squared plus h squared. And then I'll call that equation 1. And then this equation here, that is going to be 64 is equal to h squared plus b squared. And I'll call that equation 2. And I think if I do just subtract them, I'll get rid of the h's. And then I'll solve for b, and then I can sub it back and solve for h. Whichever way you want to do it. There's no perfect way, or it's not like there's only one way. So 1 minus 2 or 2 minus 1. 2 minus 1 probably a little bit better because it avoid negatives. Yeah, 2 minus 1 should do it. Okay, so 2 minus 1, that'd be 64 minus 36, which is 28. And then on the other side, it would be the h squared would cancel. We had b squared minus 10 minus b all squared, like that. Okay, so 28 is equal to b squared minus 100 minus 20b plus b squared. And then 28 is equal to b squared minus 100 plus 20b minus b squared. Okay, that's pretty good. So what do we have here? We have 128 is equal to 20b. That means that b is equal to 128 over 20. And that is approximately, 64 over 10, which is 6.4. Okay. So then I can just substitute that back into there to figure out my h, and then I can solve. So 64 is equal to h squared plus b squared. B squared is 6.4 squared, which is what, 40.96. And then h squared, therefore, would be 23.04. And then when you take the square root, it'll be 4.8. So there you go. Last step, put that back into there, 15 times 4.8. And that is 72 is the area of that trapezoid. In the diagram, PQRS is a rectangle and T is the midpoint of RS. The inscribed circles of triangle PTS and triangle RTQ each have a radius of 3. The inscribed circle of triangle QPT has a radius of 4. Determine the dimensions of rectangle PQRS. All right. I'm going to have to section off a few of these. I'm going to label them. All right, so I drew a bunch of lines. Let me explain. The blue lines are just tangent lines, right? They're all meeting at right angles because those circles are tangent to that rectangle. And they told us the radii. So, all of these are 3. This is 3, this is 3, this is 3, and so on. For the small circles, like that. And then for the big circle, they told me the radii is 4. So those are 4, and so on, right? So 4, 4, and 4. Now everything else, unfortunately, I don't have any kind of value, so I've got to insert some variables. So this red line here, I will just call h in terms of its component unit length. And then from here to here, that part I will call z, just from here to here. And let's see, what else can I label? From here to here, that part I will call x. Actually, let me draw that again. This distance from here to here is x. So I'll call that x. Now, you all know the properties of lines that meet at tangent points that they're equal. So, for example, Q extends to this point, that tangent point, but Q also extends to that tangent point. So those two lines are equal. So that means the distance from here to here is the same as the distance from there to there. So that's also x. And this is 3. And then this from here to here, I will call y. And then since t is the midpoint, this is also y. And I think that should be enough. And that was a 4, by the way. Okay. So now we can start creating some equations, and those equations will help us solve. So let's make our first Pythagorean relationship, and I'm going to use this triangle right here. And in that triangle, this side is x plus 3. So we got x plus 3 squared. This side is the same as that, which is y. So we got y squared. And that's going to equal the hypotenuse, which is, let's see here. I've got to label a couple things here before I tell you what it is. Otherwise, it'll be a little too confusing. I've got to first draw a line from T to there. There we go. That will help. Now, by the same principle, this is 3, right? From there to there. So this distance from here to here is essentially y minus 3. And therefore, by the tangent rule, this distance from T to here is also y minus 3. And then we have to add to that x to get the full length of that hypotenuse. So I hope that was clear. So the hypotenuse is actually y minus 3 plus x, all squared. Okay, so this is my equation number 1. Let me just get the equations first, and then we'll, expand them and solve them and all that stuff. Okay, second equation that I will need is hopefully a little simpler. And it basically has to do with the altitudes from there to there and to there to there. Over here, as you can see clearly, it's 3 plus x, but it's equivalent to this, which is h plus 4, the way I have labeled it. So that's my equation number 2. And then we can also, before we continue, have to explain another Pythagorean relationship. And I guess we'll just go back to the same triangle, which is right here. And in that triangle, we can see that, again, this side is 3 plus x. So we have 3 plus x all squared. And this side is y. That's just y. And it equals the hypotenuse. And the hypotenuse can be written also, see, from there to there is y. Therefore, from here to here is y. And then we just add that, which is z, the way I had labeled it. So it's just y plus z, all squared. And I think we can call that equation 3, and I think that should be sufficient. I think if we manipulate these, we should be able to solve it, hopefully. Okay, so where do we want to start here? These are some pretty decent equations. I think it's good enough to solve for the dimensions of the rectangle. All we really need to do is find the value for x and y, and we will have the dimensions. Okay, so let's see here. If I let 1 equal 3, that should be fine because this is the same as that. So that means this must be the same as that. So that means that y plus z squared is equal to y minus 3 plus x squared. Correct? So if I just take the square root, I don't think I need to expand. It'll just be that y plus z is equal to y minus 3 plus x. Y's cancel on both sides, and therefore z is equal to x minus 3. Okay, I hope that helps. Okay, let's go back now to this guy. There is another Pythagorean relationship that you can hopefully see, and that's involving this triangle right here, this one. This is a right angle, since that's a tangent point. So that means that z squared plus 4 squared is equal to 8 squared. So that means that we have z squared plus 16 is equal to 8 squared. And we can therefore sub that back into here. There's going to be a square root involved though, but hopefully that won't be a problem. So let's see here. We would get that h is z squared plus 16 under the square root sign. Sub that back into there, we get 3 plus x is equal to z squared plus 16 square root plus 4. So that means z squared plus 16 under the square root sign is x minus 1. Okay, good. We can square it. Square both sides, we get x minus 1 squared is equal to z squared plus 16. Okay, that's good. And then this is definitely going to be beneficial because now we can substitute the value for z. So we have x minus 1 all squared is x minus 3 all squared plus 16. Okay, great. So we have one variable, and hopefully this will give us the value for x. Okay, expanding x squared minus 2x plus 1 is equal to x squared minus 6x plus 9 plus 16. X squareds go, so that's good. And then we just get 4x on this side. All the numbers become 24. X is 6. Look at that. All works out. And now we have to figure out, what do we have to figure out now? The dimension, so y. We have to somehow figure out y. So where can I put, I can just put it in any one of these equations. Just put it there. So if x is 6, we got 6 plus 3 is 9 squared plus y squared. And then this becomes, x is 6, so y, x is 6, so y plus 3 all squared, like that. So this is 81 plus y squared is equal to y squared plus 6y plus 9. So y squareds cancel. So 6y is equal to 72. So y is equal to 12. Is that right? Yeah, y is 12. Okay. All right. All right. So the dimensions, if x is 6 and y is 12, so that means this whole side is 2y, so that's 24. And this side is x plus 3, which is 6 plus 3 is 9. So it's a 24 by 9 rectangle. Determine with justification the fraction p over q, where p and q are positive integers, and q is less than 100, that is closest but not equal to 3 over 7. Okay. So we have to figure out p over q. I'll use a capital Q, it's just more comfortable. and q is less than 100, but they're both positive integers, so that means it's got to be greater than 0. So q is 1, 2, 3, or all the way up to 99. All right. Well, we want to have p and q as close as possible to 3 over 7. So that means whatever it is, if we took p over q and subtracted 3 over 7, we want to minimize this, whether it's positive or negative, because p over q could be greater than 3 over 7, and therefore this would be positive. But if it's less than 3 over 7, it would be negative, so I got to take an absolute. So this is what we have to minimize. Minimize. Okay. All right, so let's do this fraction. What is that? 7p minus 3q over 7q. So if I want to minimize this, this, of course, I got to keep that in absolute value. But the denominator 7q is going to be positive because q is a positive number. If I want to minimize this, I've got to concentrate on making this small, minimize that, but I could concentrate on making that maximize, correct? In a fraction, the numerator, you make it as small as possible, and denominator make as large as possible, and that would overall minimize that number or fraction, whatever. Okay, so let's work with that. So let's concentrate on the numerator now. 7p minus 3q, the absolute value, we got to minimize. Now, p and q, they told us, are positive integers. So that means that 7p plus minus 3q is also an integer. We don't know if it's positive or negative, but it is an integer. Now, the absolute value of 7p minus 3q would, of course, be a positive integer. Okay, so we want to minimize it. So the smallest positive integer is 1. Correct? So that means we have to make sure that 7p minus 3q, the absolute value, is equal to 1. So that means 7p minus 3q is either positive 1 or negative 1. Okay, so that hopefully makes sense. Now we turn our attention to the denominator, which is 7q. We want to make that as large as possible. Well, q is a number between 0 and 100. It's an integer, and the largest possible integer it could be is 99. So largest q equals 99. So 7q, I guess, would be 7 times 99. That's the largest we could possibly make it. Okay, so based on these conditions, this one and this one, let's see what we get. So here we go. Now, we are not 100% sure that q equals 99 is going to be working for us. Why? Because p and q both have to be integers. Q we can choose as 99, but it doesn't guarantee that p will be an integer. So let's see. Let's start with the largest, and let's see what happens. So if q is 99, what is p? 7p minus 3q is equal to 1, or 7p minus 3q is equal to negative 1. If we can find integer solutions to either one of these, then we've got our answer. When I substitute q equals 99, I get 7p minus 3 times 99 is equal to 1. When I solve for p, unfortunately, I do not get an integer. I get 42.5, approximately. Okay, so that didn't work. Let's try this one. 7p minus 3 times 99 is negative 1. When I do that, I get p is equal to 42.3. Again, not an integer. Okay, no problem. Let's keep going here. Let's try our next best value for q, which is 98. 7p minus 3q this time equal to 1. When I put q for 98 and solve for p, I get 42.1. Okay, not an integer. When I put it in that, I get 7p minus 3q equals negative 1. When I use q equals 8, I get P equals to 41.8. Okay, again, not an integer. Keep going. When Q is 97, I'll just tell you that when I did this, it's 41.7, and for here, it's 41.4. Okay, doesn't work. How about Q equals 96? This is 41.3, but when you put Q equals 96 into this equation, you get P equal to 41. So there you go. You got yourself, without too much pain, an integer value. So that means that when Q is 96, P is 41, and therefore the fraction P over Q is 41 over 96, and that is what minimizes the difference and therefore this 41 on 96 is the closest fraction to 3 over 7. So therefore 41 over 96 is the closest fraction to 3 over 7. The baseball sum of two rational numbers, a over b and c over d, is defined to be a over c over b plus d. A rational number is a fraction whose numerator and denominator are both integers and whose denominator is not equal to 0. Starting with the rational number 0 over 1 and 1 over 1 as stage 0, the baseball sum of each consecutive pair of rational numbers in a stage is inserted between the pair to arrive at the next stage. The first few stages of this process are shown below. Stage 0, 0 over 1, 1 over 1. Stage 2, they've inserted the baseball sum, which would be as defined over here, that a plus c and then b plus d. Stage 2, they insert their baseball sums in between, and then stage 3, they do the same thing. Prove that no rational number will be inserted more than once. Okay, so let's say this is a over b, and this is my c over d. What you would insert is this, which is, by definition, a plus c over b plus d, right? And it is. 0 plus 1 is 1, 1 plus 1 is 2. And also, we have to take into consideration that this is bigger than that. So that means that a over b is less than c over d. So that means that AD is less than BC if you cross multiply. And therefore, if you put everything on one side, you get an inequality that says BC minus AD is greater than 0. Okay, so we also know that since this is A over B, that this guy will be greater than that guy. So therefore, I can write that A over B is less than that baseball sum, which is A plus C over B plus D. Correct? Same thing, if you cross multiply here, you get that A times B plus D is less than B times A plus C. Correct? So if you put everything, if you expand, AB plus AD is less than BA plus BC, and then you put everything on one side, you get BC minus AD because the AB's cancel out. Again, you get the same result. And then this was C over D, correct? Just like it's up there. And then this is less than that. So same kind of story. A plus C is over B plus D is less than C over D. And you do the same thing, cross multiply, and you get A plus C times D is less than C times B plus D. So that means AD plus CD is less than BC plus CD. And therefore, since the CDs cancel out, we can write BC minus AD. Again, same result. So now we have an interesting situation, correct? That we have proven that this is indeed going to be true. And this tells us that every rational number which is inserted at any given stage is strictly between two rational numbers on either side. So if this is the rational number that's inserted, it's strictly between a over b and c over d. Therefore, once a given rational number is inserted, every other rational number which is inserted must be either strictly larger or strictly smaller, as the list at each stage must be strictly increasing. Therefore, no rational number will be inserted more than once.